Yeah, so we're doing proving angles similarity. What we've done in the past was proving angles congruent, which is where we had angle, side, all those. We had 5 of them. Now we have 3 more that can prove similarity. So for our similarity, the first one is called angle similarity. When you guys write this out, you have to put the A, and then the little tilde sign, the little squiggly line. So take a look at angle similarity. It says if 2 corresponding angles are congruent, then the triangles are similar. So we need to prove that these 2 triangles are congruent based on the angles. Let's take a look at number 1. Angle A is 75 degrees. What is that congruent to in the small triangle? Angle D. What about angle C, which is 31 degrees? That's congruent to F. So, for it to be angle similarity, you have to have at least 2 angles that are similar, or that are congruent. Do I have at least 2 angles that are congruent? Yes. So this would be angle similarity. Take a look at the second one. Alright, there's no numbers here, but that's okay, I don't need numbers. They gave me these 2 angles. Angle V is congruent to angle Y. I know that because they put no little arcs there. So that also tells me that angle X is vertical angles. So now do I have at least 2 angles that are congruent in each triangle? Yes. So this would be angle similarity. Any questions on this? Our directions here says that write the similarity statement. We're not writing that right now because we've done it. We'll do it in our notes. Alright, the next one is side similarity. So it says if all corresponding sides are proportional, then the triangles are similar. So proportions, we've done this already. Let's take a look at this first figure. This side of QP, which is 3, matches what in the big triangle? TS, which is 6. Alright. 4 matches what? 8. And 5 matches?
10.
Matches what? 10. Good. Alright, so I'm going to make a proportion out of this. I'm going to write 3 over 6 is equal to 4 over 8 is equal to 5 over 10. I just went from the small triangle to the big one. Notice that when you guys do this, you have to stay consistent. I can't do 3 over 6 and then 8 over 4. That doesn't make sense. I'm starting with my small triangle, so everything on the top proportion is from the small triangle. So let's reduce all of these. What does 3, 6 reduce to?
1 over 2.
1 over 2. What about 4 over 8?
1 over 2 also?
1 over 2. What about 5 over 10?
1 over 2.
Alright, so is our proportion the same for all of them?
Yeah.
Yes, so therefore I can prove that this is side similarity. So what you have to do for this lesson is you need to check to make sure that it is side. If all of our ratios are the same, then it is confirmed that it is side. Why could this not be side or angle? Did they give me any angles here?
No.
No, we can't just make that up. They gave me 3 sides, so my option are 3 sides. Side similarity. Alright, look at number 4. 30 matches up with what?
24.
24. What about 32? What does that match up with?
25.
25. And what about 35?
28.
28. Alright, so let's do this. I have 30 over 24. 32 over 25. 35 over 28. I want you guys to simplify those fractions and tell me if you get the same thing, the same ratio. When you simplify, do them one at a time. So do 30 over 24. Math, enter. Max, what did you get for your first ratio?
5 over
Okay, 5 over 4. Did you get the second one yet?
4.
What did you get?
32 over 21.
Alright, so that one didn't reduce. So what about the last one?
5 over
5 over 4. Alright, so can this be side, side, side? Do I have the same exact ratio all the way through?
No.
No, so we're going to write, this is not similar. So not in a squiggly line, because that's what that means. So we thought it could be side, side, side. We checked it, it's not. Does that make sense? A little bit easier than doing the triangle congruence, I think. You had 5 of those to figure out. Let's look at the last one. Side, angle, side similarity. So side, angle, side. If two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. Alright, so let's see here. I always like to check to make sure I had at least angles first. Angle K is congruent to what? N. Alright, so we're good there. Angle K is congruent to angle N. Alright, so I have my angle. Now I'm going to check to make sure that my sides are congruent. 8 is going to match up with what? 6. And then 20 matches up with 15. So let's try those proportions. I'm going to write 8 over 6 is equal to 20 over 15. Alright, grab your calculators. Let's check this proportion. What is 8 over 6?
4 over 3.
4 over 3. What about 20 over 15? 4 over 3. So do I have matching ratios?
Yeah.
Yes. So this will be side, angle, side similarity. You guys have to make sure you're not getting into a habit of just seeing, oh, this is side, angle, side, and then marking it down. You have to be able to check your proportions. Alright, number 6 is an important one. You'll see it again. Do you guys see how there's basically 2 triangles here? I have a small triangle I'm going to highlight in yellow. And then I have a big triangle that I'm going to highlight in light blue. Alright, so we're going to see if this could be side, angle, side. Where would my angle be? You all put it away. No? Listen to what I'm saying. Which angle is the same in both triangles? In the yellow and the blue triangle, which angle is there for both of them? A shared angle. A, D, B, C, or E? D is just one angle right there. Guys, so you see this? Angle A is a shared angle. Angle A is the vertex for both of those. So that's my one angle. Now I'm going to check my side. What is my short side for the yellow triangle? On this side. 15. Alright, and 15 matches up with what side of the blue triangle?
Oh, wait.
Huh? Guys, look. Here's the small triangle. If that's 15, this side matches up with what in the blue triangle?
B, C.
Why are you just stop making up letters? I just not even asking you for letters. Look at the small triangle, that's blue. Look at the bigger triangle.
Oh,
This blue side is the same as what side in the red triangle?
25.
25. Look at the other side. 12 is the same as what? What is that
21.
proportional to? 21. So now do your proportions. Simplify your rationals. What's 15 over 20 reduced?
35.
What about 12 over 21?
4 over 7.
Are those the same ratios? So this is not simple. Any questions there on this sheet of paper? Alright, so now let's open your packet. Today's three goes. So it's proving triangle similar. Okay. Alright, this says, are the two triangles similar? If so, by the similarity statement and by what postulate theorem they are similar. Alright, let's see here. I think I will do it the right way here. Alright, so we are going to practice our similarity statements. Alright, so I have three ways to prove triangles similar. What are they? We just talked about them.
I got AA.
Okay, AA similarity. What else? Side, side, side.
Yeah.
And then
Side and both sides.
side, angle, side. So those are your three. Angle, angle similarity, side, side, side similarity, or side, angle, side. Take a look at number one. They told me that angle R is 45 degrees. What is angle R going to be congruent to?
Angle 3.
Angle V, that is also 45 degrees. Okay? So if these are alternate interior angles that are congruent, what do we know about angle S?
Sure.
Yeah, good. They're vertical angles. So that means we're going to put two arcs there. So I have angle, angle similarity, side, 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 and side, angle, side. Which one would this be?
Angle, angle.
Angle, angle. That's all I can put. It's either that or nothing. Okay, we're not done yet. We're going to practice this. Our similarity statements. Let's say that triangle RWS is similar to what triangle? RWS. What'd you say, Max?
CBS.
BBS. Good. That is your answer. You told us to name the postulate, which we did. It's similar by an angle-angle similarity. And then we had our angle or triangle congruency. Nate, stay with me, please. Look at number 2. Let's think back to unit, I think it was 3 or unit 2. No. Oh, 4. Alright, look at angle number 2. What do these little hash marks here mean? What type of triangle is that? Starts with an I.
Isosceles?
Good, isosceles. So that tells me that my base angles are congruent. So if this angle is 68, what is this angle going to be?
68.
68 as well. How can I find my vertex angle? What do I do?
180 minus 68 minus 68.
All right, let's do it. 180 minus 68 minus 68 to give us our missing angle.
44.
All right. Let's check on the other triangle. They told me that my top vertical angle was 62 degrees, but I also have an isosceles triangle. So how do I find out what my base angles are?
180 minus 62.
180 minus 62, and then what do you do?
Divide by whatever number that is.
Divide by 2.
Yeah.
So do 180 minus 62, and what do you get?
118 divided by 2 is 59.
All right, so my base angles here are 59 and 59. Are my angles here congruent? Do I have the same numbers between both triangles? No. So it's going to be not similar. I can't prove that this is anything because it possibly could be angle, but my angles in both triangles are not congruent, so it doesn't work. Any questions here?
No.
All right, look at 3 and 4. Number 3. Now that we've practiced this kind of triangle before, I have a yellow triangle, that's the smallest. I have another triangle that's bigger than that, which is the blue one. What is my shared angle here? Which of these angles are the same for both triangles? S. So I have my angle. Now let's check my sides. 24 is going to be the same as what? No. Look at the blue triangle. We're going from yellow to blue.
24 to 12.
Nope. This blue triangle is this whole entire side.
Here's the add up on it.
Yeah.
24 over 36.
Did you get that same thing, Max?
Yeah.
Alright, so my small triangle was 24. The whole side of the blue side was 36. Let's look at the other side. I have 16 in the small triangle. How do I find what the blue side is? 20. Alright, let's check our ratios here. 24 over 36 reduces to what? What'd you get?
2 and 3.
Good. What'd you get for 16 over 24?
Yep.
Over 3? Alright, so would this be angle, side, 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 or side, angle, side? Side, angle, side. Good. So we're going to write side, angle, side, similarity. If I want to write my similarity statement, triangle SPQ would be similar to what? SPQ would be similar to what? Huh? SPQ is the yellow triangle. Now look at the blue triangle. It starts with S, and what goes next? Look at the blue triangle. We went from S to P to Q.
Oh, that's hard.
SRT. So my answer is side, angle, side similarity because, or and therefore, triangle SPQ is similar to triangle SRT. All right, look at number 4. What could this possibly be? I have all sides, right?
Here.
So it could possibly be side, side, side similarity, right? Let's check. 32 matches up with what? With a small triangle.
Uh,
22. 45. Matches up with what? 30. And then 60 matches up with 40. Let's find our proportions. So I have 32 over 22, 45 over 30, 60 over 40. All right, simplify your ratios. All right, Max, what do you get for 32 over 22?
16 over 11.
What about 45 over 30?
3 over 2.
All right, so I don't even really have to check this last one, right? Because I know it's not, they're already not the same. So is this going to be side similarity? No, it's going to be not similar because my ratios are not the same. I didn't check the last ratio because I didn't need to. The first two weren't the same. Any questions here? All right, number 5. We have 2 triangles here. Look at this yellow triangle here. I can fill in one angle because E is a vertical angle. So what can I fill in for the left part of E? What do you think, Lance?
That is vertical?
These two are vertical. So this is 35, what's that side? 35, it's congruent. Alright, so now we can find out what this bottom side is. There's how many degrees total in the triangle? Alright, so do 180 minus 100 minus 35, so we can find out what the last, what angle Z is.
45.
45. Alright, so on the other side, what's angle R going to be?
100.
100. Do I have at least 2 angles that are similar? Do I have at least 2 angles that are the same? Sorry, congruent.
Yeah.
Yeah, so this would be angle, angle. It is not going to be angle, angle, angle. It is just angle, angle. So your similarity statement, let's say that triangle AZE.
My God, everything keeps jumping around.
Well, stop pushing out with your foot.
Oh.
AZE is similar to what triangle?
RBE.
RBE. All right, let's do number 6. What could this possibly be? So Paul, put your phone away. Headphones completely out.
Side angle side.
This could possibly be side angle side. Let's see if this is right. All right, do I have an angle?
Yeah.
All right, angle A is congruent to angle P, so now we need to check our sides. How do I check my sides here?
On the lowest number.
All right, so 6 matches up with what?
6.
And 10 matches up with? All right, check on your papers. Do this one yourselves, guys.
So 1 equals 5 over 4.
Okay. So Nate, is this similar at all?
No.
No, this is not. Yes. All right, 7. What do these two triangles tell me? What does this mean?
I forgot.
Starts with a P. It's proof of
Parallel.
something. Yeah, those two lines are parallel. So I can mark that G is congruent to J, because I know my vocab, which also means that F is congruent to what? Okay. What's special about angle H? They're vertical. I want you guys to do 7 and 8. We've already put on the picture, you guys do the rest. Alright, so number 7 is going to be what?
Angle similarity.
Huh?
Angle similarity.
Angle similarity. How about number 8? Two matches up with what?
3,
3 matches up with,
4.5,
and 4 matches up with. So let's simplify these numbers, what do we get?
two or 3.
Okay? What about for 3 over 4.5?
2 and 3.
What about 4 over 6?
2 and 3.
Alright, so is this side? Is this side similarity? Now look at the back page. It says, for each set of triangles, determine 1, are they similar? 2, if so, find x. Alright. I already have angles that are congruent, which also tells me that I have vertical angles. That's just what I know from my vocabulary. So, 2x, or let's start with x. This side of x matches up with what? X. And then 2x matches up with
9.
9. Now what do I do? I have x's.
Cross multiply.
Yeah, you're going to cross multiply. So x times 2x. 2x squared. 8 times 9.
72.
72. How do I solve for x here?
5 by 2.
You may not have too much room. I want to write this down somewhere in your paper. So x squared is equal to what?
36.
36. Alright, this is just like your geometric mean. What do I do to get rid of this square?
5 by 2.
No? How do I undo a square? You can take the square root on each side. So, my square and my root are gone, so I have x is equal to plus or minus. In your calculator, type in square root of 36. We'll see if we get a perfect number.
6.
We get 6. So, I can prove that this is similar by side angle side, similarity. And what do I write for x? Well, why do I not write plus or minus 6? You can't write the minus. Guys, can I ever have a negative distance, or can I have a negative measurement? If
No.
we're measuring something, can I go backwards and say this is negative 5 inches? No. So when we're talking about measurement or distance, just always use the positive. You don't have to put the plus or minus, because it really just doesn't make any sense. There's no minus. All right, for the next one. 39 matches up with what?
24.
No, it's what everyone thinks, but it doesn't. 39 matches up with
X over 6.
x or x plus 6. So that means that 2x minus 4 matches up with 24. In order for me to check my ratios, I have to have numbers here. I can't check a ratio of x plus 6 over 39. I can't do any work there. So, when it says similar, we're just going to write not similar. Because I don't even know if it could have been. Yeah, it can't either be side angle side. Yeah, this is nothing. We're not doing the third one because this requires factoring, which you guys have not learned yet, so we're going to skip it. Let's go to the word problems. Alright, so at a certain time of day, the 1.8 meter tall person standing next to the Washington Monument casts a 0.7 meter shadow. At the same time, the Washington Monument casts a 65.8 meter shadow. How tall is the Washington Monument? So when it asks me a question, I know that's going to be my x. I don't know what that is. It says it's asking me how tall is it. So what you should do is draw a picture. Here's my little man. It says at a certain time of day, a 1.8 meter person. So I'm going to take a measurement of him. He's 1.8 meters. Sitting next to the Washington Monument. He has a 0.7 meter shadow. Okay? Says at the same time, the Washington Monument, so let's draw that here. Say this is the Washington Monument. Has a 65, what's it, 65.8?
Yeah.
65.8 meter shadow. How tall is the building? And I can create a triangle out of both of those. Your drawing would not be drawn to scale, but as long as you label your pictures, you're fine. There are many ways that we can make a proportion. Eli, tell me how you want to make a proportion here.
I don't know.
What do you mean you don't know? There's 4 numbers, but there's 4 things that we can make a proportion.
Oh. Yes, now I get 1.8 over x.
Okay?
So 0.7 over 65.8.
Good. Eli could have said 1.8 over 0.7 is equal to x over 65.8. He could have went backwards. He could have started with 65.8 over x. It does not matter as long as your proportion is consistent. So 0.7 times x is 0.7x. What is 1.8 times 65.8?
118.44.
118.44. Alright, now what do?
Divide by 0.7.
Divide by 0.7. Alright, so what is x going to be?
169.2.
169.2, good. You want to know how tall the Washington Monument was? It is 169.2 feet according to these calculations.
Meters.
Will be in meters? Oh yeah, you're right. Thank you. Any questions on number 9? Okay. Let's look at number 10. Alex was touring London and saw the top of Big Ben in a puddle on the street. This is Alex right here. Alex is 6 feet tall, so we labeled this 6 feet, and was standing 10 feet away from the puddle. So here's the puddle in the middle. Create a triangle there. They want to know how tall is Big Ben. And this piece is if Big Ben is 60 feet from the puddle. Nate, give me a proportion.
So it's gonna be 6 over x
Okay,
and 10 over 60.
good. You can do that. Nate stayed consistent. He went from the small triangle to the big triangle on both sides. That's perfectly fine. Or you can do 6 over 10 is equal to x over 60. All right, let's cross multiply. 10 times x,
X,
6 times 60.
360
All right, how do I solve for x?
divided by 10.
Okay, so how tall is Big Ben?
36 feet.
It's 36. 36. Any questions here? All right, let's look at number 11. It says John is 6 feet tall and is standing 4 feet from a tree. If John's shadow is 12 feet long, that's his shadow, how tall is the tree? All right, so take a look at this. I basically have 2 triangles in one. I have the red one and I have the blue one. So I don't know how tall the tree is. That's what they're asking me. How tall is the tree? Well, that's going to equal x. What's my proportion here? Okay, I see what you're getting to. Let's do the red triangle first. 6 over what?
12.
12 is equal to, now look at the big triangle. What goes on top? No. This is the small triangle, right?
Yeah.
Look at the big triangle. What side is this? X. Over, what is this whole bottom here?
16.
16, good. All right, you guys do the math here, tell me what you get. So you should get 12x. What did you get for 6 times 16, Eli?
I got 96.
Okay. And then what did you do?
I divided 96 to both, not 12.
Alright, so divide 12, so we get x by itself. So x equals. Should be an 8. Did you get that, Eli?
Yeah.
Alright, good. And your homework is homework C. It is very similar to our notes. You could possibly get homework C done and checked before you leave. If you don't work on homework, you can work on your add-ons because those are due next week.
Thanks for water.
You make it water.
Yearly.